Boom. I think that'll work. I'll have to do a little fiddling. Yeah. So, great presentations today. I mean, I'm learning a lot too. I'm really enjoying it. I hope everybody else is enjoying it. I think earlier on, Arnie said, this is, wood is cool. Well, I think, bonded wood is freaking really cool. So I think it's really taken it to where we need to go. Let's see here. Got anything? Okay, there we go. So, we kind of came up with a new adhesive 30-odd years ago. We introduced it in Europe. At that time, became the most tested adhesive to ever go through the German process. We thought it was pretty neat adhesive. Gave you a lot of different benefits. It could change the manufacturing processes. So we introduced it to the marketplace, and we had some early adapters. So like KLH was one of the early adapters. I hear stories from our colleagues in Europe. They started in a small shop or a garage with a tube of glue, putting some pieces of wood together, seeing if it really worked. And they said, yeah, this is pretty neat. We can take wood and we can make it into mass wood elements. We don't need fancy heat presses, and we don't have to worry about the size of an RF. We can cold press big billets of wood. So that kind of got the whole ball rolling for us. And through the years, we came over to North America. I think in Canada we probably became the most tested adhesive to ever come to Canada. Then to the U.S., probably the most tested adhesive ever come to the U.S. It was new. It was different. Everybody wanted to know how it worked, if it was really good, if it really did what we told them it would do. So, as time went on, I gave a lot of presentations over the last 20 years. A lot of it tends to be on, the adhesive technology, how it works, certification, stuff like that. But now, we're at a point where we want to kind of talk about the fun stuff. We're actually gluing wood together now. We're making products. We're making interesting things. A few things I skipped over back then, kind of who is Henkel? We kind of dealt with the glue, the chemistry, how it works. So I thought I'd do a little bit on who Henkel is, which is the parent company of our adhesive, which is the Loctite Bond. So it's a well-established company, founded in 1876. It's a family-controlled company. We are the world's largest adhesive manufacturer. We are also the largest adhesive manufacturer into the cross-laminated timber market. We have 48,000 employees worldwide, 169 manufacturing locations, 17 R&D sites. So, we're a pretty good-sized company. But that being said, it sounds pretty big, sounds kind of scary. But just like when we started with KLH in this little garage putting glue on with tubes, I've done that all over the country. Wood is such a cool product that we can, innovate endlessly. I think CLT is probably just, still the tip of the iceberg. There's a lot of new, different types of products to come out. So, and we're the type of company that will jump in there and we'll get our hands dirty, help develop new products. We've got the depth and the resources and the knowledge to do this. So in our adhesive business, we're not just wood. As you know, probably many of you might know the Loctite name. So we are in all sorts of different industries, automotive, transportation, general assembly. We're in electronics. Probably the screen of your phone is bonded 5 layers of plastic with an adhesive from us. We do packaging, consumer goods. We do a lot of consumer adhesives. You'll see our products on the Home Depot shelves. But, we are also a big industrial adhesive supplier, so supplying to many different industries, doors, RVs, windows, wood, CLT, glue lam. So we're a pretty diversified industry, and we have a lot of brilliant people that help us develop new products, help work with people like you looking to try and invent the next great thing. So, like I said, over the years, I've given all these sorts of presentations, but now, we're getting ready to make stuff over here. We want to start, getting the product on the, get our wheels to the ground. So we're going to look at process advantages, end use advantages, market advantages. And the big thing with our adhesive that we're currently selling to the CLT market is that we can process product quickly in a cold process system. So we have a good open time, but we have a very fast set time. So this gives the ability to make product quickly, ecologically, and economically. So I'm going to go into a couple of projects. We're lucky to be able to kind of pull from a vast array, having hundreds of customers and thousands of projects out there that have used our adhesive. So I'm just going to kind of delve into that a little bit. So here we've got, let's just use our imagination here. So imagine a free-span structure, a free-span roof structure. So no columns, no pillars. 270 window openings in the ceiling of this structure. So imagine windows shaped like the opening of a tree canopy. So you've got random shapes all over the place. Imagine this structure is made from wood. So then imagine this structure covers 1.6 acres without a support in the middle. Is this impossible? No, it's not impossible. It's absolutely possible. So this is the Elephant House Zurich Zoo in Switzerland. It's 73,000 square feet inside with no interior support, 262 feet of free span, 2.2 million pounds of CLT, 600 pieces, 3 layers thick. Well, 3 layers of 3 layers. CLT engineered like beams, but with compression and tension in multiple directions. So the engineers, they took a lot of time. They made miniature models. They had little blowing wind tunnels to replicate snow loads and various things. So they figured out where the strength axes are. So it gives a free-form appearance with a significant portion of the ceiling in as windows. So down in the bottom corner there, that's an actual scale, well, close to a scale elephant, I think, so compared to the size of the structure. So this is the structure itself under construction. So there was a massive scaffolding erected underneath because these pieces were kind of laid out in a supported manner, and then once they were all in place, the window openings were cut out in a strategic form so that we still had those beam and sort of supporting axes in there. So you can kind of see in the one picture up in the right-hand corner, that's the CLT, so it's 3 layers, but there's 3 of them stacked on top of each other, and they're all screwed together. The actual portion that you see up in the left-hand corner is it's not CLT, that's another wooden decorative sort of structure that goes on top of it. So here you can see this is the finished product. This was completed, I think, last year. The design was to replicate a canopy in a forest, so when the elephants are walking around, it feels like they're in their natural environment. So looking up from the bottom, you kind of get this appearance of light coming through a tree canopy, and then the elephants get to live in the normal, in a nice environment inside the structure. So to me, I've been to this structure. It's amazing to see it in person. The scope and size of it is hard to imagine just in pictures. But this is something that I think Chris said 2 years ago you couldn't even imagine anything like this being built out of wood, and today we're doing it. So I picked a few other random sort of projects that caught my attention. This is a library in Venezuela. It's using CLT both in sort of a beam and column application, so it gives a lot of design interest. I think, for me, this catches my attention just the way it looks. I think it has a interesting use, and I'm seeing a lot more when I go to Europe, CLT being used in vertical sort of column applications as well as beam applications. This one is from our friends at Structure Lam, and this is a similar sort of concept as to the library we just saw. So here we're using CLT, also being used kind of like a column and a beam. It's, I think it's another interesting use for CLT. But then you can also do whimsical things, things that, here we have the Termite Pavilion in London, England. So they cut a certain pattern out and stacked and connected the CLT to create this interesting looking building that you can walk through the middle of it. Then, of course, you have your sort of more conventional, what we've talked about a lot at this conference, apartment-type dwellings, office buildings, which are very, which is going to be the big driver. But, it's also nice to see what the interesting ideas that our engineers and architects can come up with. This was a recent one with Nordic engineered wood. So this is in Chicago. I think it's very simplistic, but it has that ultra-modern look to it. Something that would have been hard to achieve in the past without CLT. The Timber Tower in Germany, I don't know how many might have had a chance to see this, but this is a 125-meter tower made with CLT and timber. The idea here is that you can build taller towers with wood, and you can build them in various locations, whereas if you were using steel, which was conventional for this type of wind turbine tower, you're dictated by the diameter of the steel that you can transport. So you'd be hindered by underpasses on roads and rail limitations. Here you could put the whole unit into containers, drop them on a site, and assemble it anywhere, and you could go, they feel they could go up to 250 meters with a unit with a CLT tower. So this is actually completed now. It's in Hanover. I've heard that there's now going to be 6 more installed in Europe. So it's and it's it's a carbon capture. We heard a lot about carbon capture. So versus here we're trying to generate ecological energy. Why would we want to use a steel tower when we could use a wood tower? But then we go to a nice. Here's a simple structure. The structure itself isn't made of CLT. It's sitting on a platform of CLT. This is on sort of granite ledging. So, but it's a humble sort of structure. And I think, moving forward, we're looking at grand structures, we're looking at huge projects, but, we also need to look at where we can use CLT in other applications that, may be more along the going to the masses. So those are a few projects that, I like. They caught my eye. I think they're a little bit unique. But we'll get back into a little bit about the adhesive and how the adhesive has helped change the direction of how we approach making mass timber. So historically, adhesive systems were slow to set at ambient temperatures. Typically, they were sort of a water-based type system. You had to wait for the water to flash off. You could get a reasonable amount of open time, but your press times were fairly long. So that made, production sort of mass timber elements slow and not that economical. So when we introduced the one-component polyurethane system, where we could have, as fast as a 90-second open time adhesive that sets in 3.5 minutes, or as long as a 110 minutes, that will set in 2.5 times that, and we could suddenly open a lot of doors. We could make a lot of different products that, that were challenging to make in the past and maybe weren't economical, took more time, cost too much money. So Purbon has an engineered open time, and that means that we formulate it. You would get, if you have a press that needs 20 minutes open time, we would sell you a product that has 20 minutes of open time. Then you'd press it for 50 minutes. And it's always at the same coating weight. So winter, summer, you don't have to put twice as much adhesive on to get the open time that you need. You can always have the same amount of adhesive anytime. We're 100% solids. There's no solvents. We don't have any formaldehydes. We have very little waste. We don't have water waste. We don't have wash water. We don't have issues like that, which helps us from an ecological standpoint. It chemically reacts with the wood and cellulose, lignin. So it's not just creating an interface bond, it's creating an interphase bond. So it's actually reacting with the wood itself to affect this bond. And this is a very important thing to consider in these new mass wood timber structures that we're doing today. One thing that we haven't heard too much here, or at least I haven't yet, and I've seen it in Europe, heard it in Europe, you know, when you're building CLT homes, which in Europe, their construction methods are a little bit different. So they will build single-family homes out of this. It's economical because they built them out of brick and concrete before. So CLT makes a lot of sense for them versus us where we do stick frame. So once these structures are built, they're heated, they're insulated, there is some noise for the first month or two as the building sort of equilibrizes. You know, the wood is settling into its moisture content. There's cracking and popping and things like that. So it's very important to have an adhesive, especially in a cross-laminated application, that has some ductility to it. Conventional adhesives in the past were always very brittle, and they tended to fight with the wood, whereas the one-component polyurethane adhesives, they become part of the wood. So while they're creep-resistant and structural, they will move with the wood and reduce the amount of checking, reduce the amount of noise, reduce, you know, those type of issues. Yep. So we opened up the ability to produce mass-bonded wood elements. Here we can see, you know, a large cold set press, a large glue applicator system, material handling. Our ductile bond lines, which I was talking about, where the adhesive is now interfacing with the wood. So now we got tangential, we got longitudinal forces working in our wood versus conventional glue lam, where we always had the wood sort of moving in the same direction. And we still had problems with checking and other things with our historical sort of rigid setting adhesive systems. So, but now we've got wood moving both ways with our CLT, and we can have, and wood will move at a different rate one direction over the other. So having that ductile bond line has proven to be an even more important consideration. And of course, we don't introduce any formaldehyde or solvents into the workplace or into the final element. And when you're applying adhesive in, you know, large swaths like we do for a CLT, where we might have an open glue line 10 feet by 60 feet long, there is some concern for workers and emissions, how you, if you had solvents or if you have formaldehyde or have other things going on. So you want to have a healthy adhesive going on to these systems right at the plant level. And you know, it's nice to have that formaldehyde-free ability to promote it on the consumer level. So this is Ronald McDonald House, one of the projects structural lam had done for sick children. And I think, you know, that it kind of highlights that, you know, they chose wood as a healthy material, and you want to use a healthy adhesive to bond it with. So, you know, our mantra, you know, healthy building material, which is wood. We all love wood. That's why we're here. We're taking a healthy adhesive choice. We're creating a healthy work environment, and we're building healthy buildings. And I think, you know, that's going to be a cornerstone for mass wood moving forward. Another important consideration in the product that we offer is a two-component polyurethane resin for setting metal plates and rods and connections. And connections are a really important part of building with mass timber. This product provides exceptional adhesion to the wood side with the mechanical ability to connect with the metal side. So this is a key element we use, like on the timber tower. It's all connected with this type of system. We use it a lot globally in a lot of the projects you saw presented earlier. So the opportunities for innovation in wood construction today, I think, like I was saying, I think we've touched the tip of the iceberg. I mean, we look at the show here, you know, CLT was one of the drivers, or mass timber could be glue lam, But now we've got other innovators coming up with, there's a lot of smart people out here coming up with different ways of doing things. And, we're here to help develop those ideas, be it at the university level, be it at a manufacturing site, be it a guy in his garage. We work from that level up. So this is made possible in part through advancements in adhesive bonding, but also an adhesive company with the depth, knowledge, and resources to help support the customers and help industry innovate. So it's a big company. We have lots of resources, but we're at the ground level and we're willing to get our hands dirty. I had to mention this one. I mean, this is an exciting project, and it's congratulations to Structurlam on this, the Brock Commons. Will be the tallest wood building in the world at 18 stories. It's using our Loctite HBE 202 for all the CLT construction in this building. This is, I think, an exciting step forward. From what I hear, they're really going to try and prove out the ability, as Chris said, to put it up as fast as they can. Show that cost effectiveness. Finally, this is my own little, pet idea, that I think I talk about this with somebody at almost every show. I mean, going through all these certifications and testing and years of questioning, and then of course, mass timber, we had to burn a lot of stuff. I mean, Europe burnt a lot of stuff. Canada then, they burnt a lot of stuff. And now, we're in the U.S. and, U.S. is catching on to mass timber, and they're going to burn a lot of stuff. Fire and wood are always kind of the first thing everybody thinks of. And I think, I think we know pretty well how stuff burns now, but, we can never have too much information. But I really think that, moving forward, we need to be able to sell this product. And, proving how to put it together without it, catching fire is pretty important, I guess. But, the consumer wants to know what's in it for them, in the long term. And here, we've got this is, after Hurricane Katrina, this image is stuck in my mind for 10 years, and I've been dying to use it in a presentation. So you have this concrete house that's left standing in, New Orleans. And around it, you can see all these foundations and plots where there was houses standing there, before Hurricane Katrina. And I think, with CLT and mass timber, we can produce a house that will stand like this for much less than it would cost to do it in concrete. And of course, more environmentally friendly, more efficient. We could, and with today's extreme weather conditions, I think there's a huge opportunity all across the country. Now it's not just, we will see a mobile home park, and we always used to go, another mobile home park is wiped out by a tornado. But now you got, Hurricane Sandy and other things, so it's hitting everybody. And I think to have strong homes that can withstand, extreme weather conditions, I think it's a huge opportunity that we haven't even touched on yet. And that's pretty much everything I got. So I appreciate you guys taking the time, and I'm glad to share this with you.